When I enrolled in college to study audio production, I had one thing in mind: recording music in a studio. But I would eventually come to realize that the skills I learned in that degree program would prove to be valuable in many other areas of the audio industry, including not only studio recording, but also live sound reinforcement, sound for video and film, and AV systems integration. In this video, we're going to break down the unique challenges that come with each of these areas of audio production and the tools we use to capture sound amidst those unique challenges. Thanks to Sennheiser for sponsoring this video and supporting audio education. Sennheiser is celebrating their 80th anniversary this year, and I can't think of a better company to work with on this video, because throughout those 80 years, they've played a large role in each of these 4 distinct sectors of the audio industry, from their studio and stage microphones to their lav and shotgun mics, to their wireless systems, and even their beam-forming microphones used in classrooms and boardrooms around the world. Quickly, before we begin, if you want to test your audio knowledge and learn in the process, follow the link below the video to the Audio University exam. And if you're brave enough, share your score in the comments below. Let's start with studio recording. The goal in the studio is to capture sound that will be recorded and then distributed for playback on a variety of systems. One key characteristic of working in a studio is that the studio environment provides more predictability than we'll see in the other areas of audio. In ideal situations, you'll be dealing with a low noise floor, an acoustically treated space, and often the ability to record things in separate rooms, one at a time, or to re-record when needed. This allows recording engineers to approach microphone selection and microphone placement with more freedom, prioritizing sound quality above all else. Because the studio workflow and environment is so flexible, many studios will have large microphone lockers containing all sorts of different mics, from omni to cardioid to figure 8, and from condenser to ribbon to moving coil dynamics. It's even feasible to use more delicate microphones in the studio that may not be suitable for a stage environment. One common mic that you'll find in almost every pro studio is the Sennheiser MD421, which has been a staple since the 1960s. Of course, studio work isn't without its own challenges. One challenge that comes up a lot is the challenge of managing leakage from other instruments and sound sources within the studio space. While recording things one at a time can be appropriate in some situations, getting a group of musicians together to perform a song is sometimes essential for certain styles of music. And when everything is in one space, engineers need to find ways to isolate things without ruining the tone of the instruments or ruining the comfort of the performers. Even if you are recording things one at a time, you may find yourself in a home studio with undesirable acoustical characteristics, which might lead you to wish you could isolate the instrument from the sound bouncing around the room. There are many ways studio engineers isolate sounds in the studio to capture what they want to capture while rejecting or blocking out what they don't want, including the use of gobos, or portable isolation walls that block sound, and microphone polar patterns. The polar pattern of a microphone describes where it is most sensitive and where it's least sensitive. For example, an omnidirectional microphone will pick up sound from all directions, while a bidirectional microphone will pick up sound best from the front and the rear, while rejecting sound from the sides. You'll also come across cardioid microphones, which pick up sound best from the front and sides, while rejecting sound from the rear. This is the Sennheiser E609, and it has a supercardioid polar pattern, meaning it mostly picks up sound from the front. This polar pattern could be useful in the studio setting, or in many settings, as you'll see throughout this video, as it can be used to isolate the sound from an instrument. For example, you could point the most sensitive side of the microphone toward the guitar amplifier, while placing the drum kit so that most of the sound from the cymbals reaches the mic where it's least sensitive. Compare that to an omnidirectional mic, and the supercardioid will provide a much cleaner guitar track in terms of isolation. One thing to keep in mind when placing microphones for isolation, though, is that while the gobo or the polar pattern of the microphone reduces the amount of leakage, they also change the sound. In the case of polar patterns, this is referred to as off-axis coloration. Notice that the polar pattern of this mic is different for different frequencies. This is the case with all directional mics, and it's something you should keep in mind. Some engineers prefer to embrace leakage between microphones so as to preserve a more natural relationship between the other microphone channels in the mix, but it's ultimately a case-by-case decision that engineers have to make in order to earn their status as an engineer. There's something else that's important to note about directional microphones. They're susceptible to the proximity effect. You'll notice that when you bring a supercardioid microphone or any directional microphone closer to the sound source, it will not only become louder, but the lower frequencies will be emphasized. This presents an opportunity to strategically place microphones, not only to achieve isolation, but also to shape the sound of the instrument. And in the studio, we've got a lot more freedom to create more distance between the instruments and the mics, especially when we're recording things in isolation. As you'll see in a moment, we aren't always afforded this opportunity because in other areas like live sound, for example, the cost of placing a microphone further from the source might outweigh the benefit. I want to quickly note that there are some microphones that offer switchable polar patterns, like the Sennheiser MK8. Multi-pattern mics like this operate using two cardioid capsules, one in the front and one in the rear. If only one cardioid is engaged, the microphone is a simple cardioid. If both capsules are engaged, you have an omnidirectional mic. If both are engaged but the polarity of one side is flipped relative to the other, you have a bidirectional mic. I've got a full video on this topic, but you can actually blend these combinations to achieve wide cardioid and supercardioid patterns as well. It's a really cool topic if you're interested in learning more. Now let's look at another area of the industry: sound for video and film. Sound for visual media is often re-recorded in a controlled studio environment using many of the same tools as you would normally use in a studio. But there are also many times when the sound captured during the video shoot is the sound that you'll ultimately hear in the final production. An example of that is the video you're watching right now. And you'll notice that there isn't a visible microphone on camera. Film and video present a challenge when it comes to proximity because placing a microphone directly in front of the person on camera isn't acceptable in many cases. This means you've either got to get the microphone out of the frame or hide the microphone somehow. If you choose the get the microphone outside of the camera frame route, you've got a few choices. If you're in a great sounding room, an omnidirectional mic could be suitable, but most commonly, either a supercardioid mic or a shotgun mic are used. We've already discussed supercardioids, including their ability to reject off-axis sound and also their susceptibility to the proximity effect. And a shotgun microphone, like the Sennheiser MKH416 that I'm using currently, is typically a supercardioid microphone with an additional interference tube to further enhance the directivity of the mic. The 416 design is turning 50 this year, and it's still an industry standard for location recording and voiceover work. The interference tube works because sound approaching the mic head-on will go directly down the tube and reach the capsule here at the base. Meanwhile, sound approaching from the sides will take multiple pathways through these slits in the tube in order to reach the capsule. This combination allows the microphone to be placed further away while maintaining a clear sound that isolates the person speaking while rejecting surrounding noise. If you choose the hide the mic route instead, you might look at using something like a lav microphone. This could allow you to clip the mic to the person's clothing, to their wig, or perhaps to hide it by clipping it to the set somehow, such as the visor when filming a car scene. Notice that the proximity of the lav mic is starkly different from the proximity of the shotgun microphone. Rather than being further from the source than we might prefer, as is the case with the shotgun mic, a lav is required to be closer to the source than we might prefer. And for this reason, omnidirectional patterns are often used as they're not susceptible to the proximity effect, although cardioid lavs are sometimes used as well. Plus, omnidirectional microphones pick up sound from all directions, meaning you'll get a more consistent response as the person speaking moves in relation to the mic. This is the Sennheiser ME2. Another common option is the smaller MKE2 or Mickey-2. And while these lav mics are relatively easy to hide, you're still faced with the challenge of getting that signal from the person on screen to the recording device without visible cables. And that's where a wireless belt pack system might come in handy. Plugging the lav mic into a wireless belt pack transmitter would allow the microphone signal to be broadcast wirelessly to the wireless receiver and then fed into the recording device. There's a vast range of wireless microphones available, but the one that I use as a content creator when I need wireless audio for a video is the Sennheiser XSW Digital. I've got two variations right here. One of them has an XLR input on the transmitter and an XLR output on the receiver, which is super flexible. I can send any signal through this wireless system. But I also have one which has a lav input on the transmitter. One last thing I want to point out is that you're often recording outside when filming, and that brings a list of weather-related challenges, such as wind and moisture. To combat wind, filmmakers often either use a windscreen like the one included with the MKH416, or in extreme cases, they could use a more robust microphone covering. And though I wouldn't recommend getting the MKH416 wet, it is designed to be resilient to humidity with its RF condenser design. Next, let's discuss the challenges of live sound reinforcement and the tools commonly used on stage. This is one of the largest parts of the audio industry because it includes not only sound for concerts, but also theater, corporate events, weddings, and any situation that requires amplifying sound for an audience. The key challenge that's presented in live sound is the potential for microphone feedback. Depending on a number of factors, the sound system can only amplify the signal from a microphone so much before microphone feedback occurs. This is referred to as the maximum gain before feedback. Once that tipping point is reached, the sound from the speaker will be picked up by the microphone, amplified, played back through the speaker, picked up through the microphone again, amplified again, and so on. We've all heard the squealing sound of microphone feedback. It's awful, and it's dangerous if it lasts too long, because it can cause hearing damage. One way to decrease the chances of microphone feedback is to place the microphone closer to the sound source. That will mean you'll need less gain. But a way to increase the maximum gain before feedback of the system is to utilize the polar pattern of the microphone. You may begin to see that polar patterns are extremely useful in a variety of settings in audio production, even if the benefit of the polar pattern varies from setting to setting. In live sound, polar patterns are useful for isolation between instruments, as they are in the studio setting, but they also isolate microphones from the speakers so as to prevent feedback. And remember, in live sound, there are speakers everywhere, because we not only need to provide sound for the audience to hear, but also for the musicians to hear themselves. Picture a vocalist and a mic stand and a monitor wedge on the floor. The polar pattern of the microphone can be strategically used here to pick up the vocalist effectively while rejecting sound from the floor monitor. A cardioid mic, like the Sennheiser E835, is a common choice for live vocals, as it will reject sound from the speakers and the monitors and prevent feedback. Another common choice, which I prefer for this specific scenario, is to use a supercardioid microphone. The reason this is a bit more effective in this scenario is because the supercardioid pattern rejects sound best not from directly behind, but from just to the side of the rear of the microphone. You can see that here in the specifications for the Sennheiser E945. If you take special care to point the microphone directly toward the vocalist and place the floor wedge in the rejection area, you'll increase the maximum gain before feedback, and that means you'll have more freedom to give the vocalist the level of vocal they desire in their monitor mix. But the louder you turn up the monitors, the more potential there will be for feedback, and the louder the stage volume will be. This is why we see so many bands switching to in-ear monitors, or IEMs. Sennheiser's first series-produced IEM systems arrived pretty early on the scene in 1999, and we've seen the popularity of IEMs for touring acts and even smaller band setups skyrocket over the last decade. An IEM system, allows the monitor engineer to create a custom mix that can be fed into in-ear headphones for each musician on stage. This has the benefit of providing much clearer mixes, less potential for feedback, although there still is some, lower stage volume, resulting in a clearer front of house mix for the audience, and it has the added benefit of acting as an internal communication system for the musicians to use to communicate during the show without being heard by the audience. You'll often see a microphone on stage that's sent only to the IEM mixes and not to the front of house mix. Live sound also requires wireless systems for both microphones and IEMs to operate without tying the musicians down to one spot on stage. What's particularly challenging about wireless in live sound settings is that large festivals, for example, often have several wireless systems operating on multiple stages all at once. And this presents a lot of problems if not properly managed. If stage A and stage B are both using wireless microphones on the same carrier frequency, it's likely to cause dropouts. And that's why large festivals will usually have an entire team dedicated to managing and assigning RF channels to each stage so that the systems can work properly without interruption. But even if you're using your own system at a smaller show, it's very important that you follow the proper steps to find an empty channel and then keep your transmitter powered on to prevent others from taking the same channel for themselves. Modern wireless systems have come a very long way toward making wireless simple to manage, deploy, and monitor. New digital systems allow for more channels with better sound quality and reliability. And one exciting development over the last few years is wideband multi-channel audio systems, or WMAS technology, which can facilitate denser, more flexible RF deployments as the RF frequency spectrum continues to become more and more crowded over time. And modern wireless systems often come with management and monitoring software, such as Wireless Systems Manager, or WSM, and Spectera Link Desk in the case of Sennheiser systems. These software applications allow engineers to monitor RF activity in the area, map out free channels, and quickly deploy them before a show begins. And they also allow monitoring the battery life and the signal reliability in real time, some even offering automatic fallback channels when things go wrong mid-show. As you can see, live sound has a lot of challenges, and it's not for the faint of heart. It's important that you remain calm under pressure if you choose to venture into this area of work, because the show must go on. But with that said, some of my best memories include feeling the energy of a performance from side stage, so it can be very rewarding as well. Given that everything is so fast-paced in live sound, it's common to encounter situations where there are extremely short changeovers between bands. This has led to innovations in microphone mounting, and live sound microphones also tend to be more rugged because a fast-paced environment subject to weather changes and constant changeovers isn't ideal for a delicate microphone. One area of audio that I wish I had learned about sooner is the world of audio-video installations and integration. This has got to be the most far-reaching part of the audio industry because every restaurant, every classroom, every boardroom, arena, and theme park has audio needs. This part of the industry is also much more conducive to a regular schedule. While live sound, location recording, and studio recording might require working late on weekends or having an unpredictable schedule, engineering systems for installations tends to be a more typical 9-to-5 setup. The challenges of AV integration are not dissimilar from those we've discussed so far, but they are often exacerbated by the fact that visual aesthetics are more often prioritized than audio quality, meaning engineers often need to design microphone systems that are virtually invisible. In an ideal world, you could just put a lav mic on an instructor in a classroom or put close table microphones in front of every seat of a boardroom table. But these systems need to be operated by people who are not audio engineers. So it's important that the systems installed in these spaces provide simple operation and reliable, intelligible communication without any manual mixing. These microphone systems are intended to be mounted on the ceiling, on a table, or under a conference room display, where they won't be noticeable compared to a microphone at every seat of the table, and they won't require anything from the end users during operation. Technologies like Team Connect utilize arrays of microphones that can be mixed together with DSP, or digital signal processing, to create beams where sound inside a desired area is picked up and sound outside the area is rejected. Think of this as a much more advanced version of the multi-pattern microphone from earlier, but automatic and much more flexible. Specialized microphone systems have also been developed for situations where there are large groups of people meeting and each person may need to speak at different times. These so-called delegate systems include a speaker and a microphone in each unit, where an attendee can use the push-to-talk microphone, and each other person's unit will play that microphone through their speakers, and vice versa. It's also common to have wireless systems installed throughout large buildings, and this presents a few challenges as well, especially because many designs include centralized equipment racks. Therefore, special RF distribution systems are required to route the antenna inside of the room to the actual wireless receiver unit in a closet across the building. If you're interested in the system engineering side of audio, I think AV Systems design is a great way to make a living using your signal flow and troubleshooting skills, as well as your knowledge of microphones and acoustics. I haven't discussed it much here on the Audio University YouTube channel, but if you're interested in learning more about AV systems and how audio people can find work, leave a comment below. I want to say thanks to Sennheiser again for making this video possible, and as they mark their 80th year in audio, I'm looking forward to seeing their role in new technologies like WMAS, beamforming microphones, and immersive audio, and how these technologies will change the way we capture and reproduce sound as audio engineers. But no matter what path through the audio industry you decide to follow, there are some key skills that you'll need to have. And that's what I'm discussing in the next video that's on your screen now. So click that video and I'll see you there.